I was just telling Richard here that I watched The Martian last night to get myself in the mood for a space talk. I guess I should have watched Star Trek. But anyway, it is Wednesday, March 9th, and I'm joined by our resident cosmology group leader, Richard Schmidt. And as I teased before, we're going to be discussing Planet 9. There's a new planet floating around in the outer reaches of our solar system, and it is not Pluto. On the last show, we discussed Pluto and why Pluto is no longer a planet. So I think if we're discussing a new planet, I think we should quickly recap what classifies a planet, which I think kind of was decided back when they decided Pluto wasn't a planet.
Yeah, what happened was they found so many other objects about the same size as Pluto.
Yeah.
They said, now wait a minute, we're getting too many planets out there. Let's call them dwarf planets.
Yeah.
So they got demoted. And one of the fellows that was instrumental was Mr. Brown at California Institute of Technology, and now he's part of the group that found Planet 9.
Yeah. And wasn't another thing about it is it had to, I think the phrase they used was it had to clear the neighborhood of its orbit, meaning that it had to...
had to be massive enough
to
clear out anything in its orbit.
It's orbiting the sun, and it can also have its own satellites, moons and things.
It could, but it doesn't have to have that.
It doesn't have to have it,
no.
Okay.
But then they had another criterion too. It had to influence the orbits of other objects that it came near.
So that's what I was getting at.
And that's how it led into this new discovery of Planet 9.
Gotcha, Planet 9. And just going back to Pluto real quick, Pluto did not do that. Pluto and Eris and some of the other dwarf planets didn't influence the gravity of other objects enough to be classified as planet. Am I correct?
I can't really comment on that,
something like
but
that.
It's probably true.
Yeah, and this is just a point to go back and just recap for our audience real quick what classifies a planet, because we're about to talk about a new planet.
Exactly.
So tell us about Planet 9. They haven't named it yet.
No, just suggested that Planet 9 was a good start off because we did lose our 9th planet when we called it a dwarf planet.
Yeah.
So Pluto is designated as a dwarf amongst many others. They found many more of those dwarf planets after the declassification of Pluto. And so at the California Institute of Technology, they were looking at these objects that are out there in space, way out there, and they noticed that they're just floating around doing strange things, and nobody had any idea that there was another object out there, and somebody suggested, well, maybe there is. Maybe there's one that's so massive that it influenced these other objects into certain orbits. Oh, okay. They started doing that. They did mathematical simulations on computers. And sure enough, it turned out that these clusters of small objects, they could be dwarf planets, they could be icy objects that aren't really large enough to consider as a dwarf planet, but they were floating out there in this region, but they had orbits of their own, and these orbits were suggesting there might be something disturbing them.
And if we're talking, I'm looking at the picture right now we have up. This is of our solar system. I'm trying to pinpoint for our audience what region of our solar system we're speaking about. And I think if people are looking at the picture, we're talking about the outer reaches beyond that second belt of rocks, which I think is the icy, rocky region you're discussing. The Kuiper Belt, they call it?
They call it the Kuiper Belt. And in that Kuiper Belt, Pluto's at the inside edge.
Yeah.
And so it goes out a lot further than Pluto.
Okay. And I heard it possibly takes this planet 10,000 years to orbit the sun, something like that?
They said at least 10,000. It might be as much as 20,000.
Wow.
So it's really getting out there. Take an average, be 15,000.
So anyway, go back to what you were discussing when I interrupted you about the solar system.
Yeah. So they said, well, supposing there's this massive planet out there, and it's orbiting around, what might happen? They did the simulations, and it predicted that these other objects would start periodically changing their orbit from being in plane with the solar system to be perpendicular to the solar system. And lo and behold, it was true. When they went through that analysis and they found out what was going on, it fit like a key in a lock.
So if I'm understanding you, if I'm going to use non-physics terms to describe it, Earth orbits at more of a horizontal axis.
That's
You're
right.
saying Planet 9 is going to become a sort of a
No,
vertical.
no. Planet 9
It's going to be
coming. It is at an angle to the plane that the Earth is in.
okay.
But as it was coming around, it was influencing these other smaller objects, like the dwarf planets, to start going in another way, perpendicular to the planet.
What's going on out there? The Kuiper
And
Belt.
it doesn't
Crazy.
stay that way. It periodically goes down and then comes back up, and then goes down and then back up. And that's the influence of this massive planet. And they're saying it could be 10 times the mass of Earth.
And so did they detect this strange orbit first before they realized, I think this is caused by a planet, or was vice versa?
They had all these objects and they didn't know why they were doing what they were doing.
Okay.
And so they started doing these mathematical models. And they say, gee, if we got a big, massive planet going around and it's causing these other orbits to be disturbed, they should periodically twist. And when they put that into the equations, and it did, they say, wow, we got pretty good evidence. They're saying now it's about 90% sure that this is really true. And they've got telescopes here in our area, on the Western Hemisphere. They also have telescopes elsewhere on the Earth looking for this planet now. They're searching out there for real because this is so strong evidence.
And what would these telescopes see? Certainly not a super clear high-res picture.
No, but they will see the reflection of this massive planet.
Okay.
And that's it. If you see it, now you got it. Until you see it, it's a theory. Sorry, but it's a strong theory because all the other data seems to indicate it's really there.
And supposedly it is much, much bigger than Earth.
Yeah.
It could possibly be the biggest
I put some numbers
in the
down.
solar system.
I think they said it was 5 to 10. It says the mass is estimated to be 5 to 10 times that of Earth.
And you can see a side-by-side comparison right there on the screen for you of what they estimate the size of it is, which is pretty incredible. And would that be bigger than some of the others in our solar, like Jupiter, Saturn?
It's not quite the size of Neptune, as I recall, but it's getting up there.
Yeah.
And they said, had it stayed in the plane of the other planets, that it probably would have turned out to be like a gaseous planet. Jupiter's gaseous, Uranus is gaseous, Neptune is gaseous. This one, they think, probably has a small atmosphere, but not as gaseous as the others.
And mostly ice because of the...
Mostly ice.
It's in the coldest reaches, farthest from the sun. Yeah.
And, I mean, when you get out that far, it's so cold that things like carbon dioxide would be in the ice state.
Yeah. And so how do we think this planet got there?
Well, they're thinking that the planet was originally in the plane of the other planets. The planets pretty much stay in a plane. And Jupiter's got a very strong gravity. And so does Saturn. So maybe one of those two influenced the orbit of this ninth planet and flung it out into this very large orbit that takes so long to go around. We're saying 10 to 20,000 years to go around once. It's a huge orbit.
And this flinging occurred, we're guessing, tens of millions of years ago when the solar system was still forming. It wasn't like 20 years ago there was this planet in our solar system that nobody knew about and Jupiter flung it out in my lifetime. It's been there for as long as
it should
we've
be
known.
at the formation of the other orbits. That started 4.3, 4.5 billion years ago. Billions of years, we're talking. And so maybe a billion years after that, it got flung out, or maybe a half a billion, something in that order.
So it's been there almost as long as our solar system has been intact. It's
I
just
would
we haven't
suspect,
detected it.
yeah.
That's what I'm trying to get at.
It's just so far out, you don't find things like that far out.
We're just sending probes out there now, like the New Horizons, finally getting our first pictures of Pluto. So,
That's right.
This is a previously unexplored sector of the solar system. I mean, when I learned the solar system in elementary school, it was the sun out to Pluto, and that's where it ended. We didn't talk about what was past that. And now we got the Kuiper Belt and the Oort cloud and New Horizons and this planet. It's a very exciting time to be studying space.
A lot of things coming up that we didn't know about.
Yeah. But I assume the New Horizons probe is out. You know, he's headed past Pluto now, and now they're going to bounce him over to another dwarf planet. There's no chance.
Pretty much it stays straight out.
Okay.
But they can deviate the direction of the spacecraft a little bit.
But there's no chance they're going to reroute New Horizons to come over and check out Planet 9. Yeah, it's too far.
What they're doing is routing it towards another object now. I think it's around 2018, 2019, something like that. It will reach it, and it'll still have enough power to send back the signals to tell us about it.
Okay. That's really interesting.
And how?
But so the hope of actually getting a clear picture of Planet 9 is first they have to be 100% sure it's there. You said they're 90% sure, which is pretty good. They have to be 100% sure, and then they'll probably dedicate its own satellite, which will take 7-8 years to get there. So we don't have any hope of seeing any real images of Planet 9.
I'd say that's way out.
Decade or two, it sounds like.
Yeah.
Okay.
It's no immediate object.
Right. It's just an exciting thought in everyone's mind.
Yeah.
And we can see some artist representations of what they assume Planet 9 looks like.
Good.
Okay.
Yeah, I was hoping you'd get some pictures. I didn't have any pictures. I just had
we
some
love
notes
pictures
on
here
it.
at Channel 6.
Good.
And does it, so talking about seeing it, why couldn't we detect it earlier with the Hubble and some of the newer telescopes they've got going up now?
Unless you're pointed right at it, you're not going to spot it.
Does it reflect not as much light?
Hardly
as the other
any
towers?
light.
Okay.
It's so far out.
So it's a phantom planet, essentially, just hiding out
But
there
it
in the
will be
darkness.
enough for our astronomers to find it with the telescopes we have now. And so that's why they're searching. Now that they have an object to look for. Before, nobody had any motivation to look for it. So now they're motivated.
Yeah.
Got something real.
Now we should calm down people who think that, oh, this is so exciting, discovering new planets, maybe there's life on the planet. There's absolutely no way in the cold temperatures on this planet that there's any form of even microscopic life.
I don't know. They found life in the Antarctic, in the ice. I mean, life doesn't have to be the same form as us. Life can be of other forms, using other chemicals to form life. Life is defined as something that reproduces itself.
Yeah.
And if they can find some sort of chemical reaction that will reproduce, you'll have life. It can search out its own source of energy, and it needs some energy. That's another part of life. If you don't have energy, you have no life. And if you can be mobile, if you can move around, that's another indication of life. And so it can move around in search of the energy and consume that energy and turn it into the ability to move. You've got true life.
And that's what I mean, it's in the part of the solar system that isn't called the habitable zone. We're close enough to the sun.
Far out.
We're close enough to the sun that we get that energy, that life-sustaining
Mars is the end of
source.
the habitable zone.
Right, Mars is the end. It's still even pretty cold at night on Mars, from what I understand.
Oh, yeah.
So this is just in the most frigid part of space.
That's right.
So if something was to survive on there at a microscopic level, it has to withstand temperatures well below.
It has to
what we
live
know
in
is
that
zero.
atmosphere. Yeah. If it can't stand the atmosphere, it's not going to live.
That is interesting that Planet 9 has an atmosphere. How is an atmosphere
Well,
formed?
they didn't say it has it.
Well, you
They're
just said something earlier, postulating
that it might have.
So if it did have an atmosphere, how would an atmosphere thrive on such a cold planet like that one? I know Pluto apparently has a thin atmosphere as well.
Yeah.
So how does an atmosphere form in such a cold environment?
If it's a gas that does not turn into a solid, then it's still a gas. That's it.
Carbon dioxide will definitely freeze. So are there gases that we haven't discovered on the periodic table that have a high...
How about hydrogen?
Hydrogen, it doesn't freeze?
Not till you get way down to zero.
Okay, but I mean, it's probably even colder than zero on Planet 9. So I'm just trying to figure out what...
When I say zero, I mean 0 Kelvin.
Kelvin.
That's absolute zero.
Absolute zero. We're talking about negative...
Absolute zero,
It's like
excuse
negative
me, is
236 R0 or something like that.
on that order, yes.
Yeah.
It's defined as atoms no longer have any motion. Motion indicates heat.
Yeah.
Heat gives you temperature.
Right. I understand that. So what I'm trying to figure out is if Planet 9 has an atmosphere, is it some sort of undiscovered gas that has a high
No.
propensity for...
Any old
do
gas
we know
that,
gases that don't freeze until they reach
plenty of
absolute
them,
zero?
sure.
Okay. So there are gases that don't freeze until they reach absolute
Yeah.
zero. So it's most likely a element on our periodic table currently that's making up the atmosphere of Planet 9.
Sure.
Okay. And you suspect hydrogen?
Well, certainly hydrogen can still be there. Hydrogen is the most plentiful in the universe.
Right.
And so no surprise to see hydrogen there.
Yeah. And water, of course, is out of the question, or water as we know it.
Well, it'll be in ice form.
Okay.
That's why they say icy planets.
So what else is worth getting excited about over Planet 9?
What else?
Yeah.
That's a good question. I don't know. You're not going to go out there and live.
Nope, certainly
Don't
not.
intend to, anyhow.
If it's 10 times more massive than Earth, that would make its gravitational pull much greater. Is that correct?
The gravity is proportional to the mass.
Yes.
So if it's 10 times bigger, you got 10 times the gravity.
So we'd weigh a whole lot more on Planet 9.
Oh, yes.
Yeah.
Now, its diameter is greater, so you're further from the center, and as you increase the distance, your weight goes down. So it's a trade-off. You have to work it out mathematically to see what your new weight would be.
So if we all want to lose weight, we shouldn't all move to the outer reaches of the solar system. Maybe we should go to Mars or something where
It's
gravity is-
strictly on Mars. It's smaller than Earth, has less mass. Because it's smaller, you're closer to the center, so your weight increases, but because the mass is less, you weigh less.
Interesting.
You go on the moon, they saw when you were on the moon, the guys were jumping and jumping because you didn't have that much weight.
Solar system is a crazy place.
Mm-hmm.
Wow. So what are the chances that there's other planets out there past Planet 9? Probably pretty good.
Well,
If this one went long undetected, there's a good chance that there is
it's going
more.
to be a long time before we find it.
I know, but I'm asking you what you think.
Uh,
Is our solar system much bigger than we even anticipated
I have nothing
now?
to say that, yeah, there might be.
Mhm.
We said that Uranus had a little glitch in its orbit that made it just not following the normal orbit that you'd expect for Uranus. And they said, gee, that could only be caused by some other planet out there. And they searched for it, and that's how they found Neptune.
Mm-hmm.
So this is the same idea. They found these clusters of dwarf planets that were disturbed and postulated that there was another object, and it fit the mathematical model.
Right.
And that's why we're searching for this Planet 9. They searched for Neptune, and sure enough, they found it. Same thing happened with Pluto. There was a disturbance of orbits of Neptune and Uranus. They said, wait, there might be something else out there. And there it was, Pluto.
And I think you might have explained it before, but if I missed it, I'm sorry. How do they detect these disturbances in orbits?
Through math, you know that it's supposed to be an elliptical orbit.
Mm-hmm.
Most of the orbits are almost circular. There's a little bit of I can't even say the word.
Yeah.
Ellipticity.
Yes, it might be.
And so it gets a little more elliptical, but as you get further out, like Pluto is really elliptical, okay? And this Planet 9 is wildly elliptical. It's getting further and further away from the sun. As it passes near the sun, it's going faster, and that makes it go way out. And then it comes down, it slows down out there, turns around, and comes back down again. And so that's what forms an ellipse.
And so they use math to determine that. And what instruments on the ground here on Earth are they using to get those numbers in the first place?
Telescopes.
To measure
The telescopes can measure
orbit.
the distance,
Mhm.
measure the orbits, determine what the orbit should be, and then when they see it's not quite right, then they start searching around what's influencing that orbit.
Okay. And they all chart it out in papers and computers,
Mm-hmm.
and that's where they make their calculations. Okay. There was another, I don't think they used it for Planet 9. There's another technique for detecting planets that I think was called the wobble technique. I think that's more for far-off stars, seeing if it has its own planets.
When you're looking for a planet that's going around a star.
Right.
So now we're looking way out in space to stars. And we see the stars are wobbling. Well, what in the heck's causing the wobble of a star? Well, the postulate is if it's periodic, well, then it suggests that something's going around it in a circle or an ellipse or something like that. Now, if it's going around, how do we know that the star is moving? Because light changes its frequency. As it's coming towards us, the frequency looks like it's getting higher. As the thing wobbles away, the frequency gets stretched out. These are waves coming at us. And you stretch those waves out, it becomes redder. If you compress them together as it's coming towards you, it squishes those waves together, becomes a high frequency or bluer. And so by looking at that change in frequency, we can tell how much it's wobbling and that it's periodic. And once we know that it's periodic, we start looking to see, well, maybe there's something going around, and we can estimate how big it is from how much it wobbles, because now we know what the period is and how much it wobbles, then that will influence and what you're going to be saying the size of that object is. Well, if you had a big object, it'll wobble more.
Because the gravitational pull is causing it to wobble.
Yeah, you have a bigger mass, it wobbles it more. And so that's what we saw first. Well, we wanted to see if there's any small little guys. Well, small little guys, like the size of the Earth, doesn't make it wobble very much. And beyond that, it takes a year to wobble.
Right.
Where if you get a big guy, he could be close in, he could be going around and wobbling it pretty fast. And that'd be easier to detect.
It's almost like reading a Morse code in light form.
Well, not really. Morse, we think, is digital. Okay.
Right.
This is more analog. You're seeing it smoothly changing back and forth.
Analog is a bad word here at Green.
Analog is smooth. Yeah, I know you've had some trouble. We're fixing that up as best as we can.
So if we were on another planet, let's pretend we're on another planet or going around another star, and we were looking at our sun, we would see our sun doing this wobble thing because our planets orbiting it are tugging on it, gravity. We don't like to think of our sun being unstable, but it is just ever so slightly.
Earth is moving the sun.
Yeah.
Not much, but it's moving it. And so they wanted to do the same thing about stars further out. Can we look at those stars and say there's small planets going around them? We postulate there are, but we have no evidence. How do we get the evidence? Well, supposing the planet goes right in front of the sun. It makes the light go down a little bit, not much, about 1 part in 10,000 for the size of the Earth.
This is like 0.000001%.
That's a little thing, right?
Yeah.
So how do you do that? Well, we put a telescope that just looks at a star, in fact, a bunch of stars, about 150,000 stars at a time. It's looking out there, watching all these, and reporting back the intensity of the light over time as it stares at that bunch of stars. And is looking at all those stars simultaneously and reporting all that data. So it's a lot of data.
Yeah.
It's so sensitive, it can detect 1 part in 10,000 dimming of the light. And that's what it's reporting back. And sure enough, it found a lot of planets out there going around these stars, so that we now believe there's many, many planets the size of Earth within the habitable zone. The habitable zone is when it's warm enough to have water as a fluid, not just as an ice, not as a gas, but in between gas and fluid. Gas and ice is the fluid state.
Right.
And if you have that temperature, we say life as we know it could exist.
Which is pretty incredible.
Yeah.
So in addition to our own planet 9 here in the solar system, there is theories of a high chance of plenty Earth-like planets orbiting around other stars.
Yeah, I forget the number. It was something
parsecs away from here.
Yeah. I think it was something like 40 billion within our Milky Way. And then you got how many galaxies are there like the Milky Way? There's 100 billion of them. So, I mean, there's plenty of life in the universe as far as we can see.
As far as we know, Planet 9 for now is it in our solar system. But hopefully there'll be more out there once they start probing farther out after they've 100%ed Planet 9. Maybe we'll start detecting some other disturbances farther out as technology grows more and more.
It may be while we're looking for Planet 9 that we find Planet 10.
And will the new telescope, the James Webb Telescope, factor into probing the outer reaches of our solar system more? I hear that it has quite the magnification.
Yeah, but they're going to use that for looking at stars.
I was wondering where the James Webb factored in, if he was going to help at all.
I don't think they'll look within our solar system, but they might.
It's going to interstellar space, looking out into interstellar space.
It's going beyond our galaxy. Yeah. Well, no, it'll look at our stars within our galaxy, too. It'll look at some of those.
Yeah.
But I didn't think it would be looking for planets.
No, I don't think so. That's why I was asking. But I mean, I'm always just super curious about things like this. And it's so exciting that our solar system continues to expand. You know, how many planets were discovered when you were growing up in school? Was it?
We had 9.
You had 9?
We had Pluto.
Okay.
Yeah. We lost Pluto. Poor Pluto.
We lost Pluto. That's a heck of a story. Okay, so we're down to the end. Any final comments? You want to plug your meeting today?
Yeah, we have the meeting today for cosmology at 2 o'clock in Town Center in the music room. And we'll be covering the origin of the Earth starting from the Big Bang. So it's a topic a lot of people like.
The most important planet.
The most important planet.
Yeah.
The only one we know that has life as we
it's true.
really know. Yep.
Okay. Well, thank you, Rich, as always. Maybe we'll have to come back, and as they discover more about Planet 9, we can do some updates and talk about New Horizons and things. It's always very exciting.